All right, everybody, I hope you are doing well today. We're going to continue on. We're going to get into our normal model today. This is something you'll need to know very well. This one works nice when it works out. Tomorrow we'll get into our z-score when stuff doesn't work out, but we'll kind of get through it. So a normal distribution or normal model, you'll also hear this as a curve or distribution or model, as the definition says, is the probability distribution that can be called or that can be modeled by a bell-shaped curve that is symmetric about the mean. So you always have the mean in the middle. This bell-shaped curve is called the normal curve. Normal curves are used in a wide variety of situations to estimate probabilities, and the area under the curve is measured as a probability. That is important. So the total area of the normal curve is always going to equal 100%. So the area underneath this curve will always equal 100%. So for normally distributed data, the empirical rule tells us that approximately 68% of the data lie within one standard deviation of the mean. 95% of the data always lie within two standard deviations of the mean. And 99.7% of the data lie within three standard deviations of the mean. So the mean is usually denoted by x with the bar on top and the standard deviation with that little circle with a hat on it. So here is what the normal curve looks like in the empirical rule on it. So this is something you need to know, need to be able to recreate, and need to be able to read and understand. So my mean is always in the middle. And what I'm going to do is I'm going to create three sections. I'm going to try to make it as even as possible. Okay, so you got three sections on each side. Use purple. So this is your mean minus one standard deviation. This is your mean minus two standard deviations. This is your mean minus three standard deviations. So this is one standard deviation below the mean. If I go the other way, this is one standard deviation above the mean. So x plus 2 standard deviations and x bar plus 3 standard deviations. So this is one standard deviation above the mean. All right, so what I have here is I got my first section right here, and I did this in blue. This section is one standard deviation below the mean. Okay? This section would be another one. I did it in red. And this would be the third one. So same kind of concept. I can also do the same thing over here. And you kind of have even sections, which is nice. And then green. You can kind of see it. So what I have here, if I'm kind of looking at this section right here, this little piece is 34%. This is 34%. So what we're saying is that 34% of the data should be one standard deviation to the left and or one standard deviation to the right. So from here to here, here to here, this is 68% of your data. It should be one standard deviation away from the mean. Now, if I do the same thing with the red, the second section, that's 13.5. 13.5%. So if I add those together from here to here, that is 95% of your data. So 95% of your data is going to fall within two standard deviations of the mean. And the last one, I got 2.35%. 2.35%. So from here to here, this is 99.7% of your data. So all that leaves out and excluded is this little piece right here. And these little pieces are 0.15%. So that's saying that 0.15% is going to be away from three standard deviations on either side of the mean. So we'll kind of look at this and what this means in a little while. But this is what we need to be able to read and understand as we go through today. So the area under the curve between two x values corresponds to the probability that x is between those two values. The probability or the area under the curve can be estimated by using the empirical rule. So remember that a normal distribution has a mean x and standard deviation. Find the indicated probability of a randomly selected x value for the distribution of the data. So what we have here is the probability that x is less than the mean plus 3 standard deviations of the data. So right here, this is your randomly selected point. So it's got to be there. So I'm going to take 100%, and I'm going to subtract the 0.15%. That's going to give me 99.85%. So that's how I'm going to use my chart. Because the randomly selected, that's the 0.15 on the far right side. I'm going to take it away. All right, B, and it's just getting used to this. What's the probability that x is less than, the mean minus 2 standard deviations? So here's where the mean is minus 2 standard deviations, right here. So I want to take this, add it together, and we're good to go, because this part and this part are where it's less than. So I'm going to take that 0.15 and add it to the 2.35%, and that's where you get 2.5%. So the 2.5% chance that that number is below it. All right, I guess I can stay zoomed out. What's the probability that x is greater than the mean plus 2 theta? So here's the mean plus 2 theta, so it's greater than, so it's this section. So it's the same thing we just did. We just did those numbers, so it's 2.5%. All right, and the last one here, what is that the mean is in between x minus 2 theta and x plus. So I went from here to here. Boom, 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 boom. So if I'm looking here from here to here, this is 95%. Then I want to add this green. So I'm going to take the whole red section, so that's 95%, so the 2 standard deviations. I'm going to add the green one on the right. So you get 97.35%. And that's what we're going to do. We're going to be reading this chart, and it's not going to change. All right. So on a box of cereal, the weight is listed at 12 ounces among the box's cereal types. However, the actual rate draws approximate normal distribution with a mean of 12 ounces and percentage of deviation. So draw and fill out a bell curve and answer some questions. So this is where it's going to come into play. So I want to draw and fill out our bell curve. Your drawing doesn't have to be perfect. So remember, here's your mean, which is 12. So my mean here is 12. My standard deviation is 0.1 ounce. Okay? So 1 standard deviation to the left would be 11.9. 2 would be 11.8. 3 would be 11.7. That's down there. And if I add it, I got 12.1, 12.2, and then 12.3. I like to go ahead and write my percentages too, so you can remember this. So that's 68. Wow. 68. 95. And the big one's 97. And you also got all your little pieces. So 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. So that way you don't have to keep flipping back and forth. You have everything there, and that will help you out. So let's look at a couple questions. So what is the probability that the contents of a randomly selected box of cereal is within 0.1 ounce of 12 ounces? So here to here. So that's 11.9 to 12.1. And that's the middle section, so that's 68%. Cool? So how many boxes of cereal of 5,000 can a manufacturer expect to be in this range? So you'll take your 5,000 and you're gonna multiply it by 0.68. And you get your calculator, type it in, and that is 3,400 boxes. So we're going to use our chart to answer questions. If you got your percentage, you don't have to draw your percentages every time, but that also helps a lot. It makes things quicker. So scores for a certain professional exam, one more, and then we get on to some other stuff, are approximately normally distributed with the mean of 650 and a standard deviation of 100. So if I just draw it, so 650, 550, 450, 350, 750, 850, and 950. And we can go through and draw our other stuff if you want to, but for save time, I won't. So what is the probability that a randomly selected test score is between 450 and 850? So between here and here. So remember, this to this is 68%. This to this is 95%, and that's the gap I'm in, so 95%. Out of 1,000 randomly selected test scores, how many would you expect to be in this range? So 1,000 times 0.95, that would give you 950 tests. What is the probability that a randomly selected test score is between 450 and 750? So it's here to here. So that's gonna take this and this, which is the 68%. Then I'm gonna add this piece right here, which is 13.5. And that will give you 81.5%. And you can kind of fill in stuff as you need. All right, I hope this helps. If you got questions, let me know. Pause it, kind of relook at it and see what you can do. So lastly, let's go to the calculator stuff. Now, what happens when you do not, or when you want a probability that does not land exactly on a standard deviation? It's not one of the exact places on the normal curve. This is where a calculator is going to come in hand, and this is where the z-score is going to come into play too, that we're going to do tomorrow. So the calculator here, second bars, normal CDF, left bound, right bound. This is so important if you're going to do it. If you don't have a calculator, you have to use a z-score. If you do have a calculator, you can type it in. Some notes, notice the extreme left is negative 9999 or any other very large negative number or very small negative number. And the extreme right will be a very, very large number. So the mean speed of cars along a piece of highway is 56 miles per hour. Standard deviation is 4. So if we draw our normal curve, so you can see this. Oh, that's real bad. So here, my mean is 56, minus and 4. So 52, 48, 44, 60, 64, 68. Okay, so what is the probability that a car on this highway has a speed between 45 and 55? So you see how those are not exact on the calculator or on the curve? So here's what we're gonna do. So I wanna know what the probability it falls between 45 and 55. So what is this probability is what the question is asking. So on my normal curve, it doesn't fall on an exact spot, so I'm gonna use my calculator. So I'm gonna do my normal CDF. If you use your calculator, I wanna see this written out so I can see it. So your lower bound, so 45. Your upper bound, which is 55. My mean here was 56, and my standard deviation is 4. And that's exactly what I would type in the calculator. And when you do that, you get 0.39831, which is roughly 39.831%. All right. And then what is the probability that a car has a speed greater than 62 miles an hour? So I would do my normal CDF. Since 62 is not on there, it's greater than, so X is greater than 62. So my smaller number here is gonna be 62. It goes on forever, so that's why I'm gonna put the 5 nines. And then 56 and 4 for my mean and standard deviation. And you would get 6.68%. Cool. That's how you can use the calculator. So if you got questions on that, please let me know. Make sure you write your normal CDF if you do that as well. All right, the last one I want to look at. So a survey indicates that people use their computers for an average of 2.4 years before upgrading to a new machine. The standard deviation is 0.5 years. So that tells me my mean is 2.4. Standard deviation is 0.5. So find the probability he or she will use it for less than 2 years. So less than 2 years. So if I draw my normal curve, just so you can see it, 2.4 is in the middle. I don't care about the right side. 1.9, 1.4, 1. So you can see, well, that'd be 0.9, I guess. 2 years is a little bit, oh, it's right here. So it's here, so it's less than that. So what is x is less than 2 years? So it's not on there, so my normal CDF. My lower bound, it goes on forever, so that's the -5/9. Upper bound would be 2. Mean is 2.4, standard deviation is 0.5. And I would want to see that to show me that you use the calculator. Once you type it in the calculator, you get 21.186%. All right, so big things here. Know how to use the calculator if it's not exact. I would screenshot that, I would star it, I would put it somewhere where you can get it. And also know the empirical rule. Know what it means, know your percentages. Keep this somewhere that you can reference it very easily. And you got all your information. 68% of the data lies within 1 standard deviation, 95% of the data lies within 2, and 99.7 lies within 3.